My name's Alex Miller. I'm a senior engineer at Alfresco, working primarily on the cloud for the last 6 months, developing new features as part of the services team. The title of the talk has changed slightly, so we're going to talk about more than just actions. We're going to introduce you to behaviours as well. This is basically a beginner's level course to introduce you to simple extensions of the Alfresco content management system. So if anyone's expecting something more advanced, then feel free to leave if this is too low level for you. The talk's based on talk given by Roy Wetherell last year and material provided by Jeff Potts via his ECM Architect website. Okay, so what are we going to talk about? First of all, we're going to talk about what actions and behaviours are and why they're important in Alfresco and Alfresco extensions. Then dive into more detail about how we implement behaviours with example code, and we'll do the same for actions. And this will culminate in a small demonstration at the end. The demonstration code will be available via the speaker resources. It's not there right now, but it will be by the end of the conference. Okay, the slides are already up there, so if you want to play along, if you can't actually see some of the detail on the projector, then if you've got your laptop, you should be able to find the slides now. Okay, so let's crack on. So, why are actions and behaviours important to Alfresco? We could talk about content modelling, but that's a whole different subject. So at the start of this talk, we're assuming that you've got a content model. Actions and behaviours basically allow us to extend Alfresco beyond just content, properties, things like that. They allow us to add intelligence to our extension. They basically make our extensions smart, allow us to add new features, so notifying users about things. I don't know, some complex notification mechanism. Maybe you want to post some content to an external website or something like that. It also allows us to react to changes to other people's services and extensions. So basically, this is where we start adding actions and behaviours. Allow us to start adding functionality beyond just content modelling. So a smart extension has a content model, a set of behaviours and a set of actions, and then we've got something that we can actually interact with and use. As I said before, we're not going to go into lots of detail about content modelling, but in order to demonstrate the application, we're going to basically show a simple sort of shopping cart functionality. So we're going to have assets within our, we'll have an asset aspect which will allow us to basically select it, post some notifications, and then we'll be able to add these assets to a shopping cart, a purchase order. And we'll do some things around the status of those as well. So moving on, behaviours. This basically shows how behaviours are provided within Alfresco. So we have various different services within the core repository. The base one node service, we have check-in, check-out service, versioning service, and things like that. And these services define what we call policies. Policies are basically, they're an interface that is an extension you can implement, but it basically says it's implementing the gang 4 listener pattern. So it's saying this service is going to publish events. If you implement this interface and register to listen to these events, you'll get them. And the policy component is the core coordinator for this functionality. So your services will define the policies, they'll register them with the policy component. And when you're implementing your behaviours, you'll register, you'll bind with the policy component to receive the events that the services are providing. So here we basically, on the left-hand side, you have a policy component. It's a condensed version of the node service policy. So we've got things like before create node, on create node, content update, or content updates is probably from the content service. But essentially, your service says I'm going to fire these events, and the extension that you're writing basically binds to those events, implements a policy interface, and will receive those events. We're not just limited to implementing behaviours in Java, we can also do it in JavaScript. But again, we'll show you that in a minute. There's different types of bindings that we can make. So the services say they will publish events. These basically then allow us to filter down when we want to receive those events. So for example, the node service will publish an event every time a node is created. So if you bind at the service level, you will get an event every time a node is created within the repository. Similarly, so below that, we then have ways of sort of filtering the events we get. So at the class level, we basically combined two specific aspects or specific content types. So we only get node-created events when that specific aspect or when that specific content type is created. Associations allow us to register for events when associations are created. And again, we can filter that based on a particular association type or the association name from the parent type. Similarly, we can do the same thing for properties. So we can, again, filter on property types or particular property names within other content. So how do we register a behaviour? Well, the easiest way is through JavaScript. So this is basically within your extension you will have a Spring context file. So within that Spring context file, we basically can register our behaviour using Spring configuration. So here we're basically registering class policy on the add aspect code, on the add aspect policy. And we're saying we're only interested when new assets, this is our custom content type, gets added to the repository. At the bottom, we specify the behaviour. So we're saying this is a JavaScript behaviour. The JavaScript file is located within the class path. This is add asset aspect JS. So yeah, this is basically the simplest way to register a behaviour. So we have our add aspect JavaScript, and that can essentially be anything. If you want to, so here we have a simple implementation of it. This is basically just sending an email to say this asset has been created. The sort of key thing at the top is you have this behaviour model passed in to the JavaScript. If you want to see more about the details of the information that are passed into that, then the script behaviour class will show you what's there. But essentially here we get a node that we're acting on. We're taking that node and we're sending an email to the owner of that node to say that. So this has access to the JavaScript API, which may or may not have all the functionality that you want. So depending on the skill set within your organisation and what you're actually trying to achieve, JavaScript is one way of doing it. Or if you want fuller access to the more extensive API, then you would probably implement things in Java. And that's what we'll show you next. So the first thing we need to do with the Java class is again bind our behaviours. We could do it in the same way that we did before through Spring configuration, but as you probably noticed, there was quite a lot of XML there just to register that behaviour. So it's probably easier to do it in code. So from our Spring Beam, we have an initialization method which is binding via the API. So again, we're binding class behaviours here. So the policy component would have been injected into the class that's implementing our behaviours, and then we're essentially using the API. At this point, we start getting access to the actual specifics of the policy. So if you do a search for star policy, you'll see all the service policies that are provided within the repository. And here we're acting on the node service policies. So essentially, we're registering up on the policy name, registering the content type that we're interested in, and we're saying this is a Java behavior. So in here we're saying the implementation of this listener effectively is on the current class. It's the onAdd method, which we'll see later. And we'll also bind with a specific frequency. Now the frequencies are tied to the transactionality within the repository. So we could say at the fine-grained level that we want to receive events every time the service fires that event within a particular transaction. Now for complex processes, this could be, the same content could be getting updated 3 or 4 times, and you'll receive events every time that content is updated and that event is fired. With the first event, you'll only receive the event the first time within the transaction that it's fired. The last option is on transaction commit, and that basically fires after the main transaction has committed and will allow you to do things almost asynchronously. The first two, if you threw an exception within that behavior, would allow you to stop the transaction and get it to roll back. The last one won't. So this one's probably quite dangerous to use because if you're actually doing things that are important, you want to make sure that they happen within the transaction. But there are use cases where you would need that functionality. So we saw in the previous slide how to bind the events. So here we're showing the actual event name. So like I said, we're actually implementing the policy interfaces. Like I said, this was the node service policies. So in here, they define these methods, which we're calling. So do we have any questions so far?
How about on transaction? Like on the delete node, if we register an action, if a transaction, I know the transaction is managed by default by Alfresco.
Yep.
If transaction rolls back, then these actions also rolls back?
Yes, as long as they're part of if they're part of the same transaction. I mean, if you were doing the transaction commit, then no, they wouldn't also roll back. But yeah, again, it depends what you're doing. I mean, with these examples, you could trigger other actions that would operate outside that current transaction. As soon as you do that, they won't necessarily roll back. But as long as as long as the code that you're executing within the behavior is part of that transaction, then yes, that will roll back as well.
Like on create node, do you have any methods for on create node? So any behavior to trigger on creation of a node?
Yes, so I mean,
On node created?
yes, so on node created is, so if you create a node via the node service, that on node create will be fired.
Will be fired.
Yep.
How about like on content loaded? Because there's a node as far as
Yeah. So the content service has similar policies. So there will be on content updated would be fired and things like that. So I mean, yeah, the thing to do is look for basically these policies, service policies classes, which will define all the methods that you can listen on. So I mean, one of the use cases for the policies, say the on delete node or something like that, is to prevent something being deleted if certain conditions aren't met. So you can
already available on Enterprise 4.1.
This is from 4.0, isn't it, Neil? I'm looking for.
Sorry, I missed that. I was looking at it.
So they're asking which versions policies has been in since.
Oh, since a long time.
Yep.
For a long time, yeah.
So yeah, this stuff is in the core code and has been there for a long time. As new services are added, then there'll be new policies that get added associated with those policies. So I mean, some of the use cases for this are shown here. So you know, they're effectively giving us ways of putting rules on top of our content model, notifying other services of how things are working. We briefly mentioned we can use these things to actually block actions and cause transactions to be rolled back. So we can basically write constraints this way. So I don't know if some conditions aren't met, then you would prevent an aspect from being added or something like that. Calculating properties. So if the state of the content changes, then you could update additional properties and things like that. But essentially, it allows us to extend our model and make it a little bit smarter. So the behaviours are all basically triggered from updates to the repository, updates to the data in the repository. You're registering for data changes. The next way of basically adding functionality into your extension, and adding functionality to your extension, and with actions you can control when these updates they're not reliant on data changes and things like that. So actions can be triggered from rules, so you can set up rules on folders or content. New actions can be fired. They can be directly executable from within the UI. So we can add links to the document library and things like that, so you can explicitly trigger the actions. They can also be run from effectively cron jobs. So we can trigger these. We basically have the scheduled tasks via Quartz, which can also run actions. So actions basically just allow us to run some arbitrary code on some sort of trigger, but that's not triggered by data. So it essentially allows us to implement the gang of 4 command pattern that we just say this needs to run. Actions can have parameters, and they can also return a value. So we'll see later, when we define an action, we can also define a set of parameters that need to be passed before that happens. They can be run synchronously as part of a bigger transaction. So a behaviour could call an action. If it's being run synchronously, it would be part of that same transaction. They can also be run asynchronously, which means basically they can execute on different threads. So we can have thread pools. We can control, for long running or high load actions. We could run them on a separate thread pool with reduced or constrained resources compared to something that's in the common thread pool that can just run. So we can use that. We can control the sort of load that an action could impose on the system by running them asynchronously. They're reusable. So we said we can trigger these. We can basically trigger the actions through a number of different routes. We could trigger them from behaviours. We can trigger them through the UI. We can trigger them through cron jobs. So again, we'll go back to how it's actually implemented in the repository. So at the heart, we have the action service, which within that it knows about all the action definitions. And as I said before, we can execute them asynchronously, so we can have different queues for executing different actions. And essentially, the use case of the action service is you create an action by its name, and then set the parameters, and then basically say execute it. For the asynchronous actions, we also have a tracking service, so we can say we want this action to be tracked, and we can get updates on whether it's in the queue, running, or it's finished. The action itself, as I said, it can have parameters. We basically have definitions. So we can define the parameters in the action definition, define the parameters that we need. We can also have conditions, so we can, to our action we can say these conditions need to be met before we can execute the action, and generally that will happen before any transactional code happens. So you say if you want to check some condition on the node you're operating on before executing it, you can do that. And again, there's definitions. We also have the concept of a composite action, so we can string a number of actions together in a composite action, and they will be executed sequentially. So we saw before we had our behaviours. What those behaviours are actually doing, if you look in the demo code, was eventually calling this send mail method, changing the subject and the body depending on whether it was the asset had been added or the asset had been removed. And this is basically invoking the built-in mail action within the system. So we basically call the action service. We create the action, passing in the action name. So this, we'll go on to executors in a minute, but basically the mail action executor has some static methods that define the name and the parameters that you need to pass in to make setting up the action easier. So passing in the action name and then list of parameters. And eventually we get down here and we say we're going to execute the action. Actions typically act on node refs. So in this case, we're acting on the asset node. The last two parameters are whether we want to check the conditions before we execute it and whether we want to execute it asynchronously or not. So when we're sending emails, there can be some delay while we set up connections to SMTP servers and things like that. So we're going to execute this asynchronously. So this is how we invoke an action in the simplest form. So now move on. We'll start talking about writing our own custom actions. One way is we can extend the built-in actions that are already there. We may want to wrap the existing code in Java so that we've got conditions before we execute the underlying action and things like that. We can implement them in Java or JavaScript. So in the same way that there's a script class behavior, there is a script action executor that you can register, and you pass in the location of the JavaScript that you want to execute. We can make actions available in share. I'm going to show you later how to configure share so that the action that we implement here becomes available. They can also be made available via the rules UI, and again, that can be available in share with minimal coding. In addition to the actual action being implemented in Java or JavaScript, we can implement conditions in Java or JavaScript as well. Basically, an action is an easy way to implement a unit of work, either asynchronously or synchronously. So we move on to actually writing a custom action. So we saw earlier our model of the purchase order with items. So what we're actually going to do is we're going to implement a way to add items to the purchase order via the UI. So to implement an action, we extend the action executor abstract base class. Now, this provides a load of functionality or it provides a template method for registering the action. and creating a action definition, so defining what parameters are needed and what conditions are needed. So in the simplest case, we provide a convenient name so that we can look at it in other places. The add parameter definitions, this is a template method. So it basically gets called when the action's being registered, and at this point we build up the list of parameters that are needed to execute this action. So here we're basically saying I need to know what asset I'm going to add to what asset I want to add to the purchase order. So a single node ref basically is the requirement for this action, and then we actually have a simple implementation. So again, this is a template method. So we have an execute implementation where we get the action and the node ref of the node we are acting upon. So this will be our purchase order, and within the action we have the item parameter, and we're just going to create an association between the purchase order and the item that the user's trying to buy. So in order to get this to start to appear in share, we basically, again, need to create a share action, a share link. So this is basically it. We're defining within the share custom config XML, we're basically saying that we're going to create a doclib action, an add item action, and basically we're going to use the share form dialog. So we saw we defined that parameter definition before. Share's built-in form dialog will take that definition and create a dummy UI, or will create a UI that will allow you to enter into that with no more work. And we're basically saying here, this is basically just setting up this action here. Saying you need write permission on the node that you're acting on to be able to do it. Just some UI messages. We've then got this guy at the bottom, this evaluator, so we can set up custom evaluators within Share that decide when actions appear and things like that. So in this case, we've registered an evaluator in the Share Spring configuration that basically says, is this a purchase order? So it calls the extends the has aspect evaluator. So within Share, again, there are a number of these evaluators. We've extended one of those to test that we've got the purchase order aspect. So that we will only see this action on content with the aspect purchase order. So that basically registers the action. This next page is showing us we're now adding it to the various levels within the document library. So the document browse and document details will see this add item, menu item appear in Share. So I said before that on action form dialog will just render a form based on the parameter definitions within the action. For the node ref, it basically gives you a text box. So what we're doing here is we're actually extending that and saying, I don't want to just type a node ref into a text box. I'd actually like to be able to select it. So we've just configured a specific form for this action here. And we've basically overridden the default behavior here, and we're saying we'll use the association component, which is again built in, and that will allow you to actually navigate through the repository so that you can actually select a node ref. So, as I said earlier, actions are reusable. So, basically, within the code here, we're showing you how to use actions within Share. We can use them from rules as well, and we can use them from scheduled tasks. And they basically allow us to trigger this extended this functionality that your extensions provided from the UI or from some other mechanism that you're interested in. Do I have any questions at this point? Okay, so next bit was I was going to give a quick demo just to show you how all this stuff hangs together. I'm not 100% sure how well this is going to come out on the projector, because it is a bit small. So essentially, here we've got a couple of what I'm going to call our assets, the things we're going to try and sell. So if I go in here, so I've got the manage aspects. So yeah, that shouldn't be there. So basically the way we set this up is once we add this asset, everyone that's a member of this site should be getting a notification that we've uploaded or we've got a new asset added to the document library. So here we go. We've got a new email here. There's arcs being sent to everyone in the site. So this is basically registering the behaviour on add aspect for our particular asset aspect, and then it's calling this action to send an email. So we go back to the document library. So if you look, there's no add item here, or anything like that. So if we create a purchase order, so again, at the moment, because this isn't a purchase order, we've got no ability to add the item. Change it. At this point, our add item, menu item, has appeared. So this is the bit where the form has changed it. If I hadn't added that custom configuration, all we would see here is a text box where you could enter a node ref. What we've actually got is the ability to add the purchase order. So that's the end of the demo. Where's the play button? So that's essentially the end of the demo.